In the following question, we need to show that the following conditions are equivalent. The conditions that we are talking about is that number 1, A is a subset of B. Number 2, A minus B equals to phi. Number 3, A union B equals to B itself. And number 4, A intersection B equals to A. So what do we need to prove? That 1, if and only if 2, okay, that is they are equivalent. Let's try to do this first of all. So what do we need to prove? That A is a subset of B. Okay, we know this. Now we have to come down to the point that A minus B equals to phi. Now what does this imply? This implies A is a subset of B is same as saying that all elements, right, elements in A should be in B, right? So they are in B, okay. If all elements in A are in B, if all elements that are in B, all elements in that are in A are in B, then what would the difference between A minus B be? Then what would be A minus B? Now what is A minus B? A minus B is all elements in A that are not in B, right? That's what is A minus B. But all the elements that are in A are in B. That means A minus B does not contain any element. There is no such element. There is no such element. Therefore, A minus B is phi, because there is no such element. Okay, so that's the reasoning. Now let's look at how second is same as the third statement, which is A minus B equals to phi. Okay, A minus B equals to phi is the same as A union B equals to B. Okay, so we have to look at A union B. Now what does this mean? A minus B. Now A minus B is phi. That means there is no element such that it is in A but not in B. Okay, so that means all elements in A are in B. Okay, for the same reason as we saw before. Now what is A union B? Let's look at what let me use a different color. Yeah, A union B. A union B means elements which are either in A or in B, right? So now what are the elements in A and B? Now whatever elements are there in A are also in B, right? Plus whatever more elements in B, right? So it should actually be equal to B. Because B already contains elements in A. Okay, so that's why it should be in B. So complete B is the union, right? Is the union. That is, sorry, A union B equals to B. There is, sorry, A union B equals to B. That is there. Now let's see how third is equivalent to the fourth. Now, third is A union B equals to B. If that is given to us, how do we reach the intersection? Now, what does this mean? A union B equals to B means that everything in A is already in B. So, all elements in A are in B. Okay, that's what it means. Now, this is what it means. We need to come down to intersection. We need to come down to intersection. What does intersection mean? Intersection. So whatever the common elements are, they form the intersection, right? So elements that are in A and B, both, okay? So they are in both. So that means, so what are the elements which are there in both? All the elements of A are in both, right? So A intersection B should, in this kind of situation, should equal to A, okay? So now, because 1 implies 1 is same as, what have we proved here? So we have proved that 1 if and only if 2, 2 if and only if 3, 3 if and only if 4. So we have 4 equivalent statements. Thank you.